So today we're going to review how to calculate an IV drip rate in the easiest and most simple way possible. So what is an IV drip rate to begin with? So IV drip rates are used for gravity infusion. This is when you don't have an electric pump determining the rate at which your IV fluid flows into the patient, and instead you have just pure IV tubing, and you're going to be determining the rate at which your fluid is flowing, your IV solution be flowing, whether it be just normal saline or an antibiotic, just by calculating how many drips are flowing through this chamber. So an IV drip rate lets you know how many drips per minute you need to see in this chamber in order to have the IV running at a correct rate. So the major unit for this is going to be drips per minute. GTT stands for drips. So a big part of IV drip rates is a drop factor. So what is a drop factor? Well, obviously it's used to calculate a drip rate. Drop factor is the amount of drops you need of fluid needed to get 1 milliliter of fluid. So different IV tubing has different diameters of tubing, so the drops are going to be different sizes. So you're going to need different amounts of drops in order to add up to 1 milliliter. So thicker IV tubing is going to need less drops because the drops are going to be bigger, and more narrow tubing is going to need more drops because the drops are going to be much smaller. So IV drip rates are very simple to calculate if you follow the simple three-part formula. So the first part is going to be a flow rate. The flow rate is basically the number you would program into a normal electric pump, telling the pump how fast the fluid needs to flow into the patient. And this is calculated in milliliters per hour. It's very important that your flow rate is going to be in those units for this formula to work. I also have a video, I can put the link in the description, that shows you how to calculate a flow rate. That's pretty much a prerequisite in order to understand how to calculate a drip rate. So the second part of this formula is going to be the drop factor. This is also going to vary. It's going to vary depending on the type of tubing you're using. So just as we discussed in the previous slide, the units for this is going to be drips per milliliter. So how many drips it takes to get 1 milliliter. You're going to take that and multiply it by part 3, which is the time conversion. This is going to be one part that stays the same regardless of your drop factor and flow rate. So the time conversion, basically what it does is it cancels out units. You'll see in the next slide in the example, and it gives you the answer in the correct units, which is drips per minute. That's going to be what you want your answer to be in. That's what the drip rate is. It's how many drips per minute you're going to see you're going through that chamber we saw earlier in order for the flow rate to be correct. So here's our first example. The physician orders an IV infusion of D5W 1000 milliliters to infuse over the next 8 hours. The IV tubing that you are using delivers 15 drips per milliliter. What is the correct drip rate? So we have our formula up here, and we can calculate the first part right away because first part is flow rate, milliliters per hour. So what we're going to do is just calculate the flow rate. So none of this is important to us. Well, actually this part is. This part is important to us. So it's 1000 milliliters you're infusing into the patient over the next 8 hours. So what you're going to do is you're going to do 1000 divided by 8, and that's going to give you your flow rate. And what that gives you is 125 milliliters per 1 hour. The next part is the drop factor. So the drop factor here, as it shows you, is 15 drips per milliliter. So every 15 drops, it adds up to a total of 1 milliliter of fluid. So we're just going to put that into the formula just how it is, drips per milliliter. So 15 drips per milliliter. Just put it in just like that. And then this last part is the time conversion. And basically what that's going to do is it's going to change up our units, and this is how it's going to do it. So the time conversion is always 1 hour in over 60 minutes. this is basically like multiplying by 1, except what you're doing is changing all the units. So this is just a standard way to change the units in order to get the correct drip rate. So what it's going to do is this. You have milliliters here, so you're going to that's going to cancel with this. Then we have hours here, so this is going to cancel with this. And if you did the first two parts correctly, it's always going to work this way. So the only two units you have left is drips and minutes. So the answer is going to show you how many drips you need to see falling through that chamber in order to have the correct flow rate. So basically you're just going to multiply across 125 multiplied by 15 multiplied by 1, and that's going to give you the numerator, and then 1 multiplied by 1 multiplied by 60 is going to give you the denominator. So basically what that's going to give you is 1,875 divided by 60. You just multiply all the numerators across and multiply all the denominators across, and that's how you get this first part. But obviously we don't want it for 60 minutes. We want it per 1 minute. So all we're going to do is just simplify this, and all that is just 1,875 divided by 60. And that's going to give you 31.25 drips per minute. All we did there was divide by 60 because all we wanted it was in 1 minute units. We wanted it per minute. You're not going to be standing there for 60 minutes counting 1,875 drips. You only want to stand there for 1 minute. Now, one more part to this is the fact that you can't have a quarter of a drop. You're never going to be able to calculate that. So what you're going to do is you're just going to round to the nearest drop. So this answer would just be 31 drips per minute. You would ignore the 0.25 because you simply can't see a quarter of a drop falling through in a minute. Not going to happen. So this is basically the simplest way to calculate a drip rate. If you follow these 3 steps with all the correct units in each step, then you're going to be fine and you're going to get the right answer every time.